Let us continue in this video with the second clustering algorithm, that is what the hierarchical clustering algorithm. Now as I told you, hierarchical clustering is a tree like structure which is having a root and then the corresponding branches. Hierarchical clustering will have two types, one is a bottom up clustering and second one is a top down clustering. The top down clustering is what? Divisive clustering, means once a root is given to you, what we are doing is, once a root will be given to us and then we are going to divide it, and it may happen that this will not have. Okay, so this is what called as a top down clustering. And in bottom up clustering, which is known as a agglomerative clustering, in which we are going to form the dendrogram like structure. Okay, means in bottom up you are going to put the branches of a particular root together. Okay, so these two branches will be put together and it is joined with the corresponding one. Now as these two are divided, okay, so these two are represented by this one, okay, and then it should be communicated with this one, no? So here, so like this, whatever is grouping done, whatever the branches which were divided, those were brought together from the bottom up direction, that is known as a agglomerative clustering. That is what forming a dendrogram. This structure is known as a dendrogram, okay, like structure. Now hierarchical clustering. As I told you, hierarchical clustering is generating a tree-like structure, okay, and the output of hierarchical structuring, hierarchical clustering may be a dendrogram, okay. Now here, let us see with one example. An animal is there which is having two types. One is a vertebrate and the another one is a invertebrate. So based on the categories of this animal, I am dividing them in the corresponding branches. Okay. Now till what point this division will be continued? Till I am getting the proper group. Means one type of the fish should not be going under the mammal type. Okay, that is not a proper clustering. So this is a recursive procedure. Now as I told you, one type of the hierarchical clustering is dendrogram formation, which is a bottom up clustering. So these two branches are put together, the corresponding root is combined with the another root. So like that all combination will be done and you will get a dendrogram. Now here hierarchical agglomerative clustering, which is in short known as a HSC. Now what we are doing is, as we have seen, the two branches are grouped together, means I am joining the two clusters together to form a bigger cluster. I am proceeding here in the bottom up direction, not the top down direction. So based on the closest pair of that cluster, I will join the cluster and form only one cluster. Okay. So whatever are these two clusters, based on its closeness, I will join them together and form one cluster. Okay. Then again this cluster should be joined with its closest pair, form the one cluster. So move in bottom up direction and get a dendrogram. So which is known as a hierarchical agglomerative clustering algorithm, in short HSC. Okay. And this is also known as a merging. Now what are the criteria for selecting a closest pair? One is known as a single link. In single link, your cosine similarity measure should be maximum 1, and then in complete link, what I am doing, the cosine similarity measure I am considering the minimum 1. In average link, which is in between your single link and complete link, it is the average point. Okay. Then the next one is what? A centroid, where I am considering the centroids of the two clusters, means the distance between the centroids of the two clusters. Now as I told you, single link agglomerative clustering algorithm of your hierarchical clustering, it is considering the maximum cosine similarity of two clusters. Okay. Now here what is happening? I want to find out the similarity of the cluster Ci with the cluster Cj. Then here what I have to find out? The maximum cosine similarity. Okay. And when you are having 3 clusters, then in that case how you will proceed? Ik and Jk, similarity between these two, and out of that again the maximum value. Okay. So, means when I am proceeding the bottom up direction, it may be the case that I get the 3 clusters. Okay. Means 2 branches of one root have been united, and that I need to unite with the third root. Now, single link example, you can see that these two are merged together, then these two are merged together. Now, how I should merge? I should form a one cluster of the above two, then like this. Now, like this the clusters will be formed. This is what the single link. Now, and then finally at the root level you will get it. Now, the next one is what? The complete link, which is exactly opposite the controversy of your single link, in which I am finding the minimum value of your cosine similarity. Okay. That is why here the word minimum is used, and when the two branches or the two clusters are joined together, how to join it with the third cluster? Again find out the similarity of it with the third cluster and the minimum of it. Okay. Now, here yeah. So, the complete link example. Now, how it should be? Listen. Here instead of the horizontal clustering, I am going for the vertical clustering. Okay. So, based on your minimum cosine similarity value. Now, the mean point between them is what? The average. Here I am considering the how I am considering the similarity of the two cosines Ci and Cj. First, I should consider its absolute value of union and subtract 1 from it. Then this should be divided by 1. Then I will take the summation of all such documents which are belonging to the both the clusters, but those documents are not similar. Now, first I will find out the summation of the similarity measure of these two documents, and again the outer summation. Okay. So, here what is happening? You are averaging on all ordered pairs again in merged clusters. Okay. So, original clusters are averaged here, and again you are averaging them, means after performing the merging also again you are doing the averaging. Now, what do you mean by a good clustering? There should be similarity within that cluster instead of in between the cluster. Intra-class similarity should be high, inter-class similarity should be low. So, what do you mean by purity? How you are trying to find out the purity of your cluster? Now, consider here 3 values. What are those 3 values here? One is your red. Okay. The next one is what? Not green. I am considering the blue count, and the third one I am considering the green count. Okay. Now, this is your first cluster. How many total number of the documents are there? 6. So, I am dividing it by the 6. Now, how many red dots are there? 5. How many blue dots are there? 1. How many 0 dots are there? Sorry, how many green dots are there? 0. Then out of this all 3, the maximum will be what? 5. So, that 5 should be divided by 6. So, this is what known as the purity of your cluster 1. Now, when I am considering the purity of cluster 2, then the red count is 1, blue count is 4, green count is 1. So, the maximum is 4 divided by the 6. In the same way, I should be able to find out for the cluster 3. How many are the total number of the documents? 5. Now, I want to find out the max of your red count 2, blue count 0, green count 3. So, what is the maximum of it? 3. So, what is my purity count? 3 by 5. Okay. So, in hierarchical clustering, it is a type of the supervised learning. Whatever is your clustering algorithm, though it is a k-means, though it is a hierarchical, it is a unsupervised learning algorithm. Means without a labeled data, you are trying to perform your clustering. Now here the efficiency of your clustering is depending on what? How many clusters you want, what is the similarity measure you are using, whether you are using your cosine measure or Euclidean distance, and how you are representing your document by using the vector space model, by using the probability model, etc. So this is all about your hierarchical clustering algorithm. Thank you.